12, I can able to get a message in our class. Okay, she has sent an email. I don't know what is that. I have not received any email. Oh, it's not an email. Okay. Oh, so you are mentioning about that, you are going to inform that the class is cancelled in observance of Day of Dead holiday, which falls tomorrow. Tomorrow only, not today. It's not. So, okay. But anyway, we are having 17 students, so we'll have our class for next 10 minutes to 10 minutes. Okay. So our 20 minutes will have a class for those students who are actively participating in the today class. Okay. So I don't want to miss them. Okay. We'll continue the class for the next 20 minutes and we'll leave on exactly at, okay. No worries. So we are going to transmit a signal. Okay. So leaving a blank space in each frame that can be directed for synchronization. So when the pulse is directed, okay, that pulse will act as a reset pulse. So then only we can able to understand that the overall channels are get completed, and then it goes for the next frame. So at the end of each frame, the counter will be reset to zero. So it will again select the channel number zero. So this counting is possible with the help of the synchronizing pulse. So when the next PAM pulse occurs, the demultiplexer will set to proper channel. Okay. So one flow is completed, and again it will start the next one. So the clock pulses then step up the count on the proper sequence. Finally, at the output of the demultiplexer, a separate low-pass filters will be given to recover the original signal. The figure, what I'm going to show in the next slide, will show you the complete PAM demultiplexer. Okay, so this circuit is quite integrated one. So where we are going to give the PAN inputs at the receiving end, this is called the frame synchronization. So it's a demultiplexer switches and the low pass filter, and you're recovering the original signals. And then we are going to detect the synchronizing detector. Okay, using this, it will detect which pulse is having the maximum amplitude and is given to the clock recovery. It detects the synchronizing pulse, and then it gives the counter and decounter, and based upon that, again the one frame will be get completed. That is a one channel sequence will be completed, and again will start. Okay, it switch over from one frame to another frame. That switchover is possible by detecting the pulse, the pulse which is having the maximum amplitude. Okay, so you will be concerned about the input and output signals, but we also want to concern about this synchronization as well. The next one we are going to discuss about on the pulse code modulation. So it's one of the form of time division multiplexing. So here, multiple channels of data are transmitted in serial form. So here, what we're going to do here, each and every channel is assigned with a time slot to transmit one binary data. We are assigning some time slot. So data streams, which is coming from the various channels, are interleaved and transmitted sequentially. Whereas when we talk about on the PCM multiplexers, so these are used for transmitting the analog signals, and these are samples, okay, and they're converted to analog to digital, and the digital binary numbers, and then it will be transmitted. So these binary words are transmitted from serial format and then transmitted. So at the receiving end, the various channels are demultiplexed at the receiving end. And again, we are going, so the initial sending end, we are using the analog to digital converter, and the digital receiving end, we are going to use the digital to analog converter to receive the analog signals. Okay, so any binary data, whether it is a multiplex or not, can be transmitted by PCM. So many long distance probes or have onboard video cameras, so whose output signals are digitized and can be able to back to earth in binary format, especially when we talk about on the space systems. For an example, you are receiving some data from the space and you have to convert the data and you have to make it as a digitized and then you have to send the data to the earth in binary format. Such kind of thing, the people they are using the PCM multiplexers. So such PCM things, video systems possible the transmission of graphic images even over many incredible distances. So in the computer multimedia presentations, the video data is often digitized and transmitted using this technique to a remote source. So this is a major component of a PCM. For an example, if you're taking your analog voice, let us say that your voice will be like this, analog voice. You're converting into the digitized using analog to digital converter, and then it's given to the shift register using the clock, and then you're going to use the digital multiplexer. Okay, so this is like a one voice is coming is from one channel like this. Some similar input channels are coming. Let us say that we are getting some one, two, three, four, five, six. Okay, and then we are going to use a clock using a counter and decoder to to make this sequence by serially, and then we are going to make an encoding. Either you can make use of an encoding, or else you can make use of the amplitude modulation or frequency modulation. So that is what is a multiplexer. All the six signals are, it will be converted to a single line. The single signal will be modulated. So it will be having a carrier. So both the signals are modulated. That is called the modulation. Either you can go for the amplitude modulation or a frequency modulation. Once it gets modulated, you'll be getting the PCM AM or PCM FM. Depends upon the type of modulation. After modulation, we are going to give to the radio frequency power amplifier, and then it is given to the antenna through this antenna, either by using a twisted pair or a coaxial cable, you are transmitting your signal. So this particular circuit is available at the transmission end, transmitting end. So this is the thing. So the voice signals we are going to apply to it is digitized. Okay, where you're going to get the 8-bit parallel binary word. That is like this 10010010. For an example, this is called as the 8-bit. We call as 1 byte. Okay, for one particular signal. Okay, so that's one. So the reason why we are converting to the digital means the digital data can be transmitted serially. Okay, so where we are going to make use of the analog to digital converter for this particular purpose. So the telephone systems we are using the codec. Okay, so that will take care of the A bar D, analog to digital conversion. So analog to digital conversion means it just by converting your analog to a digital pulse, or we can able to convert as a parallel to serial conversion. So digital is always a serial conversion. Okay. Serial conversion means first it will send one, then zero, then one, then zero and zero and one and zero in a serial way. So the clock oscillator will drive this bit rate one by one. So the multiplexing is done by using a simple multiplexer. So since all the signals are to be transmitted or binary, by multiplexer will be constructed of standard logic signals can be used. So the binary converter, so they drive a decoder which will select the input channel. So the multiplexed output will be a serial data form. And then we are going to encode and we are using the coaxial cable. And then we can say that the PCM binary signal can be used to modulate a carrier. Okay. So we are going to make use of keying. We normally call as the phase shift keying, the type of modulation. So that can also be used, PSK. So these are the details of the 4-input PCM multiplexer. Okay. So for an example, you're going to give the serial data inside. Okay. It's a first data. Second, there's a serially. First, this person will go. Next, this one. So you're going to give the parallel data. It convert to the serial data, and then the third data, fourth data. Okay. And then it will be converted. This will be the PCM output. Okay. We normally make use of the simple AND gates and then the OR gate, and then output will be like this. There's a serial data number 1, 2, 3, 4 for the one particular time frame. There's a synchronizing pulse. That's what we already discussed. Synchronizing pulse will be used to start one frame and end one frame. Okay. So there is a pulse which is having the maximum amplitude, which will be acting as a synchronizing pulse to start and stop your channel. So typically the inputs will come from the ABAD converter. Okay. So the binary inverts are giving. Okay. So we are using a shift register and we are using the multiplexer. It's also called as a data selector. So we are using the gates 1 to 5. So where the serial data is used only to gate number 1 to 4. Okay. So the enable gate, we are going to make use of the gate number 5. Okay. So out of the 5 gates, The serial data is given to 1 to 4. The enable gate will be, that's a pulse gate, or the synchronizing pulse will be given to the OR gate. So now assume that all the registers are loaded. The 2 bits is reset, which will send the 800 code to the decoder, and then it will get enabled, and will enable the gate number 6, and then it will trigger again. It will trigger, the process will be get continued. Okay, so the process will be continued based upon the set of data. Okay, how each and everything will be enabled. Okay, fine. So let us talk about this the multiplexer side. When we talk about on the demultiplexer, okay. So here the receiving ends, we are going to do the same process in a different way. Okay. So we are going, this is an antenna, the data is get transmitted and received. Okay. We are using a super heterodyne receiver, and then we are going to use a demodulator. There's a there's a demultiplexer, and then with this particular circuit will be the clock to understand the end of each and every pulse duration and also the time frame. And finally, you'll be getting the original signals after the demultiplexing. Okay, so that's what is given over here. It's a benefits. Okay, and then these are the different cases what you can supposed to learn by yourself. And then we talk about on the duplexing. Okay, this is a very important one. After duplexing, we'll end the today class. Okay, so it's one of the two-way communication. What is two-way communication? I am also speak and you're also speaking. So you can be able to give the things like this, and I can also give the things like this. It's a one way, it's a two-way communication. Duplexing means, okay, the two stations are communicating. Okay, this station will transmit and receive, and this station is also transmit and receive. That's called two-way communication. Like that, when we talk about mobile, marine, aircraft radios, they are use of duplexing. Full duplexing means the two stations can both send and receive simultaneously. So, as like in our phone calls, we call as a full duplex. Okay. But you should understand that not all the systems they require send and receive capability. Some systems, they will only send, they will not receive. Okay. So from for here, the duplexing, the way of duplexing will be quite different. So here also there are two different types of duplexing. One is called the frequency division duplexing and the time division duplexing. So duplexing, it's a very important way, that is to frequency division duplexing they're using, where it will separate the two separate channels, one to send and one to receive. So let us say that, there's a duplexing frequency. This will use for receive and transmit. And here also we're having a receive and transmit. It's a concept of duplexing. So the communication parties are called station one and two. Let us say that there's a A and this is B. So station one uses a channel for F1 for receiving only and F2 for transmitting. Station two, it uses F1 for transmitting and F2 for receiving. Okay. So by spacing the two channels quite apart, so the transmitter will not interfere with the receiver. So we can able to make use of the filters to make the signals to be get separated. But the biggest disadvantage is, it makes use of extra spectrum space, which is quite expensive. But many of the cell phone systems, what we're using today, it is the very simplest methods are also reliable because we want a two-way communication. And another one will be called as a time division duplexing. Okay, so where the signals are transmitted simultaneously, so where we can able to understand that, this is for the particular time, station one for transmission, receiving, time two, this is for the one time frame. That's with respect to time, receiving and transmitting, both are things. So during the time slot T1, station 1 is transmitting, station 2 is to receiving. Time 2, station 1 is receiving. So it changes its patterns for each and every time slot. Okay, so where we make use of the converters, the primary benefit is it requires only one channel. It saves the spectrum space, but it's very hard to implement. So special synchronizing methods are used to change over from the thing. Okay, so newer third generation cell phone systems may use this time division multiplexing, duplexing. Okay, so thank you, students. Okay, thanks for your time because I don't want to make sure this one, as I already mentioned you. Okay, so tomorrow maybe your holiday, but I